All right, so we just spent some time talking about solving mazes, but solving mazes isn't the upcoming homework. The upcoming homework is finding the fastest in time tour of the moons of a planet. So we have a planet. I'm going to start by talking about Kerbin, so I'm going to draw a K that no one can read on that planet. And then around that planet we have two moons. We have the moon, which I'm going to mark in a way that isn't clear, and then we also have a second moon, which is out a little bit further, called Minmus. I mean, there's two moons, it's clear. The inner one is the moon, the outer one is Minmus. They're orbiting Kerbin. Now, in this particular problem in Kerbal Space Program, there's a couple of complications. The moon has a relatively circular, zero inclination, so equatorial orbit. So that's pretty easy to deal with. But Minmus has a slightly eccentric. Does it have an eccentric? I think it's still circular, but it's at a 6-degree inclination. So that makes things a little bit more complicated. I'm going to start by focusing on the case where we have two moons in circular orbits that are equatorial. So with both equatorial orbits, zero inclination orbits, we can think about this purely as a two-dimensional problem. So we're going to start out in a low Kerbin orbit with our spacecraft, which is going to be that triangle. So we're orbiting in the positive direction, which is counterclockwise. The moons are also orbiting the positive direction counterclockwise. But sort of the first question that we ask here is, what if we assume that the moons don't move at all? The moons are just where they are, and over a short period of time, that's true. The moons are not going to move, and they're not going to move very far. And so then we can ask, what is the most time-efficient path to get from where our spaceship is now to visit each of the moons, get within its sphere of influence, and that I guess a simplification of that would just be to get to 100 kilometers away from the target. So we want to visit the neighborhood, and we want to get an encounter that's about 100 kilometers periapsis on the target. So the first thing that we would consider is just the easy way to get from a low Kerbin orbit into having an encounter with the moon is to do a Hohmann transfer burn. So that's going to be, we want to do a burn that's going to set our periapsis to be where the moon is. Now, short duration, the moons are not going to move, but the amount of time it's going to take our ship to get from where we do our burn to where the moon is, the moon will move. But we're going to, for this example, be even simpler and just consider the cases where the moons don't move at all. Just our ship moves. That's the only thing that's going to move in this world. So the sort of two cases that we're considering with this Hohmann transfer style transfers are: do we want to go to the moon first, or do we want to go to Minmus first? To go to the moon first, we're going to wait in our orbit until we're exactly on the other side from the moon. We'll do our burn, and then we get this trajectory that's going to go by the moon. And then the result of that trajectory is going to be that we'll go by the moon, and we'll end up in a very eccentric orbit around Kerbin. After we don't do a capture burn at the moon, we'll end up in a very eccentric orbit, and then sort of the simplest way to continue this thing. So burn 1 is going to go here, and then burn 2, we're going to want to find the point that is opposite from Minmus, which isn't any special point on our orbit. It's not the periapsis, it's not the apoapsis, it's not any of the arguments of anything. But we want to burn from here until we end up with this side of the orbit raised to encounter Minmus. And that is something that we can do burning from there. It's not going to quite look like that, but we'll end up with an elliptical orbit where the apoapsis gives us an encounter with Minmus at a altitude of 100 kilometers or whatever we're doing. And so these two burns, where we're going to do a Hohmann style transfer out to our encounter with the moon, so that's an optimal delta V transfer out to our encounter with the moon, and then we'll do another optimal delta V transfer in the more general case of starting from an elliptical orbit out to our encounter with Minmus. So that's gonna, this even might be optimal in terms of delta V. We also have to consider the other path. So the other path was, we start by burning out to Minmus, then we go to the moon. And it's actually hard just by staring at this to see which is better, because we don't know how long the sort of, the coasting stages of each of these is gonna be. It could be that the configuration of where these two are is such that going to Minmus first ends up being cheaper. So the best thing to do is to search the space of options, and you can start to see that you could think of this as being a graph, but you want to search the space of options where the first option is first we go to the moon, then we go to Minmus, and the second option is first we go to Minmus, then we go to the moon. I'm not sure whether actually representing that as a graph is a good idea or not, but we could well, I mean, just by only considering efficient burns to put our apoapsis at an encounter, that is discretizing the problem space, and then we can do our graph search through the discretized problem space. But we don't want to actually do it in minimum delta V. We're trying to do it in minimum time within a delta V constraint. So our ship is going to end up having some amount of fuel, and we're in orbit. We're not going to be going into any atmospheres, so at least in the Kerbal Space Program simulation, we can calculate exactly how much change in velocity, how much delta V we have available, and it'll be the same regardless of what path we go through. So we have a couple other options here. For example, if you want to do a Hohmann transfer for an encounter out at the moon, go to the moon, come back in, and then rather than continuing our orbit out to burn opposite from where Minmus is, it might be more efficient to circularize at our periapsis again, do a faster, lower orbits are faster, and a circular low orbit is going to be faster than an orbit that's eccentric and is that's a train again. Hi, train. A circular low orbit is going to get us around the planet faster than an orbit with a periapsis at the same altitude as that circular orbit, but a higher apoapsis. So we know that if we do a burn here to lower our orbit back to our original orbit, and then from the opposite side of that orbit we burn out to go to Minmus, that's going to take less time than the thing where we wait to do our burn to Minmus until we're out on the larger orbit opposite from Minmus. So that gives us another option of what we can do, where we can recircularize our orbit. We can circularize it at our periapsis, we could circularize it at our apoapsis, we could circularize it at any other point as well, although just circularizing it at the periapsis might be the first thing to try out. But we have another option too, and that is, and this diagram is starting to get messy, so I'm going to go through this again in Kerbal Space Program directly, but I wanted to draw it with the sort of fixed position here first. Another option that we have is to just burn harder, and when we're going out to the moon, we want to burn so that we're moving faster than a sort of optimal delta V Hohmann transfer style transfer. We expend more delta V, and we could even expend so much delta V that we end up with our escape on our trajectory, with the plan that once we get to our encounter with the moon, we're going to slow down to go a different direction. And sort of, if we had infinite delta V, we could start to consider trajectories that are like, we just go straight and don't worry about ellipses at all. So these train tracks that I'm next to are the main train tracks for travel in and out of Boston. And that's why we're getting so many trains. In any case, this gives some idea of the space that we're trying to search through here. So I'm gonna go ahead and go in and boot up Kerbal Space Program, and we can see if I can talk about these options a little bit more there. And that might be helpful too.